Okay, let's go on to chapter 3. And this one's easy enough that I don't have to write down. So determine if a relation is also a function. Then give the domain a range. So a relation being a function means that 9 doesn't go to two different things. So 9, 2, 8, 7, 5, 1. They're not even repeated, so it's a function. If I would have had like 2, 0, and 2, 1, that means that f of 2 equals 0, f of 2 equals 1, and that can't be. The elements of the domain are 9, so they have them in this order. 8, 5, 9, 7, 2, 1. So it's going to be the first one. The elements of the range is a second number. So we have -2, 0, 6, 7. Now when you repeat yourself, you only write it once. 6 and 9. So it's like it's going to be B. Okay. So on the next one. Evaluate this function at these different points. This one we'll copy over. Okay, so first one we're going to calculate is if f of x equals x squared minus 3, that means f of, I'm going to color code this, 2 equals, well, wherever I see the x, I'm going to put in a 2 squared minus 3, which is 4 minus 3 is 1. F of -4 is -4 squared minus 3. That's 16 minus 3 equals 13. And f of x minus 2 is going to be x minus 2 squared minus 3. So everywhere I see the x here, I replace it with x minus 2. Now I have to FOIL this. It's x squared minus 4x plus 4 minus 3. So this is x squared minus 4x plus 1, 4x. So we have f of 2 is 1. F of -4 is 13. F of x minus 2 is x squared minus 4x plus 1. Use a vertical line test. This just means that if you draw a vertical line anywhere, it only touches it once. So yes, it is a function. Any vertical line you draw is fine here. Classify this as a polynomial, rational, root, and find the domain. So this one is a root function because it's the cube root. So it's a root function, and the domain is what numbers can you put in that are valid? Well, I can have positive and negative numbers when I take an odd root. So anything is good in here. So negative infinity to infinity. Now if it was a square root or a fourth root, that would be different. Then you just want the 0 to infinity. And that was short enough that I'm just going to keep going on to 3.2. Determine f of x, f of negative x. So here what this means is we're just going to plug in f of negative x. And let's see what we get. We get 4 negative x to the 8th. All I'm doing is simply substituting at first. Now here, the negative times itself 8 times is going to be positive. So it's just going to be 4x to the 8 minus 6. Here you're going to get negative times negative times negative. So it's going to stay negative. And I might want this like with a negative out in front. 3, sometimes it letting me write 3. So this is, and do not factor, so negative 4x to the 8 minus 6. What that means is don't factor out a 2, which you can do on the top. And then x cubed. Determine the intercepts. Now this one is easy enough, we don't have to write down. This is just a straight line that goes straight across. Y equals 11. So the x-intercepts are, it never crosses the x-axis. The y-intercept is going to be where x is 0, you get 11 here. Use a graph to determine the domain and the range of this function. So we can see here that negative 2 pi, it's asymptotic right here, and it's asymptotic to negative pi, and nowhere else is it defined. So the domain is going to be parentheses negative 2 pi to negative pi. And we use parentheses because it doesn't touch it, it's asymptotic. Now the range is all the y values. Now it looks like this is going to go on forever down here, and that's going to go on forever up there. So here we would use negative infinity to infinity. So this one I'm not going to write down either because we have it right here. On which interval is it increasing? So where is it going up? Well, it's going up from negative 6 to negative 4. Notice we only care about the y values, the x values here. So the first one is going to be negative 6 to 4. It's also increasing right here from 0 to 3. That's the point 3, negative 1. So from 0 to 3 it's increasing, and it increases from 6 to 9. Where is it decreasing? It decreases from negative 4 down to 0. It decreases from 9 to 11. Where is it constant? It's constant right here from 3 to 6. And that's it. Where is the minimum, a relative minimum? Doesn't look like there is one. No, it would be like a valley if we had a relative minimum. The function obtains a relative minimum. It has none, and it has none. It attains a relative maximum right here at 1. X equals 1. And that value is 7. Determine if this is even, odd, or neither. Now the quick answer is it's going to be even, but the way we do this, so I'll work it out, is you plug in the negative and you see what you get. So you plug in g, you can also graph it, that's another way to see it. So you plug in g of negative x, and you're going to get 15 minus negative x squared. Well, remember this has the PEMDAS says the power goes first, so this is just 15 minus x squared, but this is just the original function. So whenever you have that g of negative x equals g of x, that means it's even. If it's negative g of x, it's odd. So here it's even. Okay, for what values is f of x positive? When is this function here bigger than 0? Well, it's bigger than 0 from negative infinity to negative 2 right here, and then from 2 to infinity. True or false? F of 5 is bigger than f of 6. F of 5 is 5. F of 6 is 7. Is 5 greater than 7? No. What is x when f of x equals 7? So here we look at x equals 7 is right here. Well, it can be anything from negative infinity to 6, and then from 6 to infinity. Negative infinity to 6, and 6 to infinity.